evaluate the integral x raised to power 4 ln of x dx. So that is integration by parts because it is a product of two functions. So you check which one should be u and which one should be. So you know you cannot integrate ln of x, isn't it? But you can differentiate it, isn't it? So you let ln of x to be u. Are we together? So what you do here is to rearrange, meaning this is the same as integral of ln of x times x raised to power 4 dx. So from here, you now let ln of x to be u and x raised to power 4 dx to be dv. Because you can easily differentiate ln of x. You cannot integrate it, isn't it? Are we together there? Good. So you rearrange it so that you let u to be what you can differentiate easily. Okay? So what is your u? ln of x. So if you differentiate u with respect to x, differentiating ln of x is just 1 over what is inside, isn't it? Yes. So it is 1 over x times the derivative of the inner function. The inner function is x. If you differentiate x, you get 1, isn't it? So it means if you differentiate ln of x, it's just 1 over x. If you take dx the other side, you have du is dx over x. Good. Then now go to dv. What is dv? You have here dv is the same as x raised to power 4 dx. So for you to get v, you introduce integral on both sides, isn't it? So if you integrate dv, you get v to be equal. So if you integrate x raised to power 4, so you simply add 1 to the power and you divide by the resultant power. See, that's how to integrate a polynomial. Yes. Isn't it? You add 1 to the power, you get 4 plus 1, which is power 5, isn't it? Yes. Then you divide by that resultant power. Okay? Yes. So that is integration by parts. Meaning we have, if you have the integral of u dv, you are supposed to get uv minus integral of v du. Then you start substituting. What is your u? Your u is ln of x, your dv is x raised to power 4 d, which is the original problem, isn't it? Yes. Which is the original problem. You can just rewrite it the way it was original, still the same, to be equals to uv, isn't it? U times v. Can you multiply u times v? ln of x times 1 over 5x raised to power 5. If you rearrange, it is 1 over 5 x raised to power 5 ln of, isn't it? See, that is u times v. It is 1 over 5 x raised to power 5 times ln of x. Then minus, we have minus, then integral of v du. Can you multiply v and du? Remember, du is dx over x, isn't it? Yes. Dx over x times 1 over 5 x raised to power 5. Dx over x into x raised to power 5 over 5. You get 1 over 5 x raised to power 4 dx, isn't it? Because this x goes here 1, you remain with x to power 4. X to power 4 over 5 is 1 over 5 x raised to power 4, isn't it? Are we together?
X raised to power 4
dx over?
X raised to
power 4 over 5, isn't it? So I want to factorize 5 outside because 5 is a constant, isn't it? So 5 is a constant, so you take a fifth outside. Then inside you remain with x raised to power 4 dx, isn't it? Then you only bracket what you want to integrate, isn't it? Are we together? So you can see x raised to power 4 is no longer, it is no longer integration by parts, it is just integration of a polynomial function, isn't it? Are we together? So can you integrate it? What do you have? Here we have 1 over 5 x raised to power 5 ln of x minus 1 over 5 in bracket. If you integrate x raised to power 4, what do you get? So you simply add 1 to the power and you divide with the resultant power. See, that is how to deal with a polynomial. It is no longer a product of two functions, isn't it? So you have x raised to power 5 over 5. Then at the end you add, at the end of integration, you add arbitrary integration constant, isn't it? So if you simplify that, you get 1 over 5 x raised to power 5 ln of x minus 1 over 5 times 1 over 5 is 1 over 25. Or 1 over 5 divided by 5, isn't it? Because 5 is in the denominator. That is negative 1 over 25 x raised to power 5 plus c. And you are done. Are we together? Yes. That is how to deal with problems of that nature.